I'd like to do an angle beam calibration using the DSC test block. The equipment I have is an Olympus Epic 1000i machine, and I'm using a 45-degree screw-on wedge with a 2¼ megahertz, a half-inch diameter transducer. And I'm using the DSC block. This block has the 0 for your beam index point is machined right here. And then the radius, from the 0 to here, this is a 1-inch radius. And then from here to here is a 3-inch radius. So when I put my transducer on here, I will see a 1-inch reflector, plus 3 is 4, plus 1 is 5, and then 4 more would be 9. So I'll see a 1-inch, a 5-inch, and a 9-inch reflector. Another thing that's interesting about this block is that on the edge with the 3-inch radius, there is a 1/32 inch wide groove that is cut at 0.375 inches deep, and we use that for our reference. And also I can measure the angle of my transducer shooting at this hole, and it's 45 to 70, looks like 75 degrees scale here. So let's start by changing the range to 10 inches. Set my screen range at 10 inches. Set my velocity at 0.128 inches per microsecond, your standard shear velocity in mild steel. 0 set to 0. My range is set to 10 inches. And of course, in the trig, I have 45 degree set for my angle. And in my pulsar, 2.27 megahertz. I want to make sure that your machine closely matches your transducer frequency. So I'm going to put the transducer on, and I can see 3 reflectors. I know that's a 1-inch reflector. This one here is a 5-inch, and that's a 9-inch. So let me take down my gain a little bit so I can see that 1-inch radius at a little bit easier angle to work with. Now let's hit peak memory, and I'm going to move my transducer back and forth again to establish my beam index point, and we can see the peak memory, and right about there I'm peaked right in the middle of that signal. And you see the dialog box says P for peak memory. Let me shut that down. So that's my 1-inch radius, that's my 5-inch, and that's my 9-inch. So again, we want to mark our beam index point. This is the 0 machined. We want to transfer that to our wedge, and I have a piece of masking tape with my beam index point marked on there. Beam index point is where all my trig functions, all my measurements come from. So right now I have this transducer positioned for maximum energy. I'm going to take my gate and make sure I capture this 1-inch radius. I'm going to take it to 80% full screen height, and I'm going to press my auto cal button. I'm going to cal 0. My sound path is 1 inch, so I want to change it. Tell the machine that it's looking at a 1-inch sound path. And there he is. Alright, right there. Hit the continue button. And then I can move my gate over and capture my 5-inch radius. Or I can capture the 9-inch radius, but I'm going to capture the 5. Take that to 80% full screen height. Do a cal velocity. And change this to a 5-inch sound path. And then hit the check to calibrate. And there we go. Calculate. Calibrated. So now I'm calibrated. Let's take the gate and run it over here. My first reflector, my first radius. And we will see, take the 8% full screen height. That's a 1-inch sound path. So, 1 inch. Move that gate over to capture this. Take an 8% full screen height. And what we see is 5-inch sound path. 1 inch plus 3 inches is 4 plus 1 more, 5 inches. And then we'll see out here, let's move the gate out, and we'll see a 9-inch radius out here. 9-inch reflector. And if I take that up to an 80% full screen height, we'll see again it's 9 inches. 1 and 3 is 4, 5, 3 is 8, 1 is 9. Let me show you something else. You can flip this guy around and you can see a 3-inch. Let's move this transducer, 0 here. We would see a 3-inch. Inch, 7-inch, and an 11-inch reflector. Let me change my range to 11 inches. So my gate, if I move my gate over here, capture this guy going in this direction, we have 3 inches. And then we will come over here and this radius will be 7 inches. And then if we come all the way out here, this will be 11 inches. Sound path. So that's kind of some of the different reflected radiuses you can get on this machine. So let's take a look. Let's measure, now that I'm calibrated, let's measure the angle of my transducer. So I'm going to take my range down to something, a little more manageable. Let's take it down to, I don't know, 1.5 inches. That looks, whoops, too far. 1.5 inches. What we have here is we have a side drilled hole, and that is a 1/8 of an inch diameter. So to measure my angle, my transducer, this is a 45 degree. So here's 45 degrees up to 70. So I'm going to put about the 45 degree. And when I see that signal popping up, let me put a little more coupling on there, kind of running it dry. A little more coupling. And 45 degrees. So this hole right here, let me take the gain down a little bit. And let's hit the peak memory. And I'll look at that. Find the peak of that signal. Right about there is the peak of my signal. And if I look at the 45 degree, it matches perfectly to my beam index point. So this wedge is a perfect 45 degree. Now to set our reference level, we want to look at our 3-inch radius here. So let me move my let me open up my range so I can see that 3-inch radius, and there it is right there. I'm going to set this guy at 3.5 inch sound path. Move my gate over here and bring this guy down to 8% full screen height. Let me peak him. My gain's a little bit hot. Bring it down a little bit more. And let's peak that signal. Right there. So that's my 3-inch radius. My sound path reads 3 inches. Now let's take a look at this guy. That little notch, I said a 32nd of an inch cut that is 0.375 inches deep. So if we could look down in here, 0.375 inches down, we have a 32nd of an inch notch. If I move my gate over here, and then if I add some gain, we will see that little notch. See him coming up right here? That's him. There he is right there. Let me take him to 80% full screen height. Now that would be my reference level. Because I'm shooting down here, I'm catching that little 32nd of an inch wide notch. And if I adjust it to 80% full screen height with my gain, my reference gain is 52.5 dB. And I have a sound path of 2.65 625 inches. That's that little notch there. So that is what you would use as your reference reference setting for your gain.